Hello, my name is Mike Batty. I'm Bartlett Professor of Planning at University College London, and I'm the Principal Investigator of the QUANT project that is funded by the Alan Turing Institute. QUANT essentially is a large-scale land use transportation model. It's large-scale in the sense that we're building it for England, Scotland and Wales, the main island in the British Isles. And the reason why we're doing this is that there are many, many implications that pertain to what's happening in cities that really spread out beyond cities, basically. So things, for example, such as high speed 2, some of the new railway lines, some of the new airport developments and so on. These are projects that really require a very large scale model so that we can capture all the impacts, etc. So that's one of the reasons why we're building Quant for Great Britain. The other reason, of course, is that we want to make the model accessible to policymakers, and therefore we're actually not delivering it as a desktop version, but indeed as a web. So anybody can log on to the model, as I'll show you in this short video. Anybody can log on to the model, run it, and begin to test their own scenarios. And because we have the model in this particular form, we really need to basically make the model work very fast. So a lot of our emphasis is on making the model very relevant, very accessible, and very immediate in this particular context. Now, the model is a land use transportation model that really predicts population and employment and the flows between them. That's the essence of the model. It also takes account of different things such as land uses, green belts, housing policies, things of that sort that really pertain to what's actually happening in terms of different areas, in terms of land use, basically. Okay, so let me begin by showing you some slides which pertain to how the model works. And to do that, I really need to share my screen. So off we go. And let me load my PowerPoint. Okay, and the first thing that you can actually see in the PowerPoint is the block diagram of how we're constructing this model. The model, because it's a web-based model, most of the heavy lifting in the model is done on the server side. So to some extent, as a policymaker or user, this is not really of much concern to you, but it's very important in terms of making the model work. And indeed, many of the new techniques in computing that pertain to models of this kind, web-based services and so on, are contained in the server side. The client side is where the user or policymaker will relate to the model itself. And as you can see, on the client side, we're concentrating on visualization. You can see maps and touch tables, 3D models and so on. All of this kind of instrumentation is paraphernalia really pertaining to making the model work for the user in this sense. The next slide shows the area where we're building the model for. In fact, you can see on the left, these are the small areas, the atomic units that make the model work. In the middle there, we have population density. You can see the cities, the Greater London and the Northwest, the Midlands and so on. And on the immediate right, you can actually see, you can probably just about make out, this is a vector diagram. These are the average flows, basically, really pertain to the interactions, the flows between different places. That's pretty central to the model itself, particularly if we're looking at big infrastructure projects such as high speed 2 and so on. This is changing the basis of the flow systems in the country quite dramatically. The next slide actually shows you, there's a couple of slides that show you what it looks like, and we'll actually demonstrate this, what it looks like when we load the model. That's the splash screen, basically. We then get a variety of things we can do, such as explore the data, run the model and so on, build up different scenarios. And this is very typical of a scenario. For example, this is West Lancashire, which we're looking at Merseyside. And what I've done in this particular case is to inject 10,000 jobs into the point at the center of the picture, which is Knowsley, basically, in Liverpool, and look at the impact of those jobs on the rest of the region. The model will trace the impacts, and you can see that the impacts really relate to how near, how far away different things are from the impact in question. So there's a whole variety of things we can do in this particular way. Before I actually do that, let me actually show you how the model works. So to do this, I'm going to load a web browser, Here we go. There's my web browser come up. I'm going to load the model itself. So this is what you can do. You can do this even on a phone, for example, in that sense. So we've loaded the model in this way. I'll just clean up the interface so you can see on this side. So explore the model. So the model is running at the moment. This is what any user would see logged on from anywhere. It's sort of in the public domain. If we click on these thumbnail maps, for example, let's click on housing accessibility. It's loading from the server side the map itself. You can see that the map here is being loaded. It'll refresh itself. You can see in a moment it's refreshing itself. And we're looking at housing accessibility, the relative nearness of housing, etc. If I zoom in this particular way, you can see that the model is not super fast. We really want it to be immediate in some sense. So a lot of our activity is to make the model as fast as possible, really, to actually speed the thing up so that users would not be intimidated by waiting for a long time for the model to refresh. So this is fairly typical, and we can explore the model, etc. So that's showing you the model actually running. Let me go back to my PowerPoint and show you some of the things we can actually do with this model. And this is really where it comes into its own. So for example, here, for example, is HS2. This is the route, the proposed route for the high-speed rail. HS2, HS1, of course, is the Channel Tunnel Railway. HS2, basically, which connects London to Manchester and thence to Leeds. We're looking at the impact of that. And from the model, once we plug this in, this railway, then we can look at population change. We can also look at things such as the amount of carbon saved by these high-speed trains over and above the existing trips. And we can look at the trade-off between them. We can do this for other examples. Crossrail, for example, which is the new Elizabeth line under London, has an enormous sort of footprint across southern Britain, basically. You can see that just about make out that this is showing you the population change, the growth of population around the line of Crossrail. But if we blow it up to southern England generally, you can see that this picture shows you the total number of faster railway journeys, basically, by putting in Crossrail 2 in this context. So these are the kind of things we can look in terms of impacts. And then there is the East-West Railway plan between Oxford and Cambridge. That will also have impacts, and you can see population change and carbon saved in that particular context. And the last thing I'll show you is we've done some work on COVID-19. For example, physical distancing, social distancing on the railway basically will reduce its capacity quite dramatically. If we reduce its capacity to about 15% of what the existing trips are, then this has enormous spillover effects onto the other transportation systems in the model, such as the bus systems and the road systems in this particular context. And this leads to quite dramatic changes in accessibility. Now, I'll finish it off. Let me stop sharing the screen and just go back to myself in that sense. So let me say a couple of things. What we have here are examples really of using models, building models to be as efficient and as fast as possible, to capture as many effects as we can, and also to make them available to policymakers in the most appropriate way. And of course, the way to do that at the moment is to deliver this kind of technology over the web and to speed it up to the point where policymakers can actually explore many, many different scenarios in terms of what the future might look like. Thank you very much. If you're interested in any of this work, then please email me at mbatty@ucl.ac.uk. Thank you.